Good morning to all of you. Today we'll start introduction to flexible pavements. So in this chapter we'll get to know about basics about the flexible pavements, different layers of the flexible pavement and their functions and different types of the flexible pavement. This flexible pavement is a structure consisting of superimposed layer of process materials. Now, this layer means one layer is above another layer. So, likewise, there are different layers, and different layers are laid above one another. That's why it is called superimposed layers, and these different layers are made up of different categories of the material. Some layers are made up of subgrade soil, some layers are made up of coarse aggregate, and some layers are made up of a bituminous binder. Now, this bituminous structure should be able to provide a surface of acceptable riding quality or smooth riding quality, as well as it should provide adequate coefficient of the friction so as to minimize or nullify any chances of skid or slipping. Now, the ultimate aim is to ensure that the transmitted stresses due to the wheel load are sufficiently reduced. So, there would be different layers, and your main aim would be that the stress which would be directly applied over the top surface, the intensity of the stress will be get reduced and it can easily transfer to the bottom layer. These are the basics of the flexible pavement. Now, if we discuss about the function of the flexible pavement, so function is reduce and distribute the traffic loading so as to not causing any damage to the top layer, provide vehicle access between 2 points. 2 points means suppose there are two destinations, you are connecting these two destinations with a road, and with building that road you provide a smooth riding experience to the driver, and which road will be accessible throughout the year irrespective of the different adverse weather conditions, provide safe, smooth and comfortable ride to road users without any undue delays and excessive wear and tear to the vehicle, meet environmental and aesthetic requirements. Then it also limit to the noise and air pollution and reasonable economy. Now, if you discuss about the requirements, there are different requirements of a ideal pavement. It should be sufficiently thick to distribute the wheel load stresses in the bottom layer, that is the subgrade layer. Now, one thing is there in the flexible pavement, the top layer is of the superior material and the bottom layer is of the inferior material. So for this reason, the thickness should be designed in such a way so that the stresses generated over the top layer or stresses imposed on the top layer can easily be reduced when they reach to the bottom layer. Then structurally strong to withstand all type of stresses withstand upon it. It may be different type of stresses, it may be some compressive stresses, it may be some impact load. So the pavement material or your main pavement should withstand all types of load or all types of loading compositions. Then adequate coefficient of friction to prevent skidding of the vehicles, that's as well as smooth surface in so as to provide comfort to the road users even at the higher speed, produce least noise from moving vehicles. Now, if the road is not good, in that case, whenever the vehicle will be moving, in that case, it will create different noises. So, you have to make that road sufficiently smooth so as to reduce any type of noises produced over it. Then a dust proof surface so that track safety is not impaired by reducing visibility. Now this, if there are enough dust over the road surface, in that case what will happen as first thing, it will reduce the coefficient of friction and therefore there may be chances of skidding or slipping. And in another case, whenever the vehicles are moving, it can impair the visibility of the driver because of the dust material present over the area in that particular surface. Then impervious surface, so that water cannot penetrate through the road surface and reach up to the subgrade material. Now if the water reaches to the subgrade material, in that case what will happen, it will mix with the soil subgrade and it will weaken the subgrade, and ultimately there would be damage to the entire portion of the road. Then long design life with low maintenance. So these are the requirement of a pavement. Now, if we discuss about the types of pavement, there are primarily two types of pavement. One is flexible pavement and another one is rigid pavement. Now, flexible pavements will transmit wheel load stresses to the lower layers by grain to grain transfer through the point of contact in the granular structure. So, this point we have already discussed, that in the flexible pavement there would be aggregate. Okay, different layers of the aggregate and load would be transferred from one aggregate to another aggregate. Okay, so this type of transfer of the load is called grain to grain transfer of the loading, and ultimately the stress imposed over the top layer will be get reduced because of the area of the dispersion would be higher than the top layer, and the intensity of the loading will be, or stress would be reduced. Now, taking advantages of the stress distribution characteristic, flexible pavements therefore has different layers. Okay, and therefore as the stresses would be higher at the top layer and very much lower at the bottom layer, therefore superior materials are used in the top layer. Now if you discuss about the different layers of the flexible pavement, at the bottom one would be natural subgrade, that is your natural layer, soil layer, okay, over which you will build your road. Now if the natural soil is a loose soil, or it doesn't have enough bearing capacity or strength, in that case you need to compact some portion of the soil. Now that portion is called compacted subgrade, and generally the width or depth of that layer is varying between 150 to 300 millimeter. Now above this there would be another layer of the soil of the aggregates, and that is called subbase course. So here this size of the aggregate would be higher, and generally different type of aggregates, blast furnace slag, etc. are can be used as a subbase course. Now above this another layer would be there, that is called base course. The base course is also a layer comprising of the coarse aggregate, but here in the base course, this size of the aggregate would be lower than the subbase course, and the aggregate would be of higher quality than the subbase course. Now another function of the subbase course is whenever load is applied over the top layer, in that case some soil material can be penetrated through the base course if the subbase course is not present over there. So therefore subbase course also reduce this penetration of the soil over the base course. Now above the base course one coating of the bitumen would be there, and this coating is called prime coat. Basically this prime coat will act as a adhesive material which will add on to the another layer, that is called binder course. So basically this binder course is an extension of the surface course. Now in the surface course we will use bituminous material along with the coarse aggregate of a size of smaller fraction, generally less than 10 mm or 10 to 12 mm nominal size we will use over there with the suitable content of the bitumen. Now in the binder course, the bitumen content used with the aggregate would be lower than the surface course. Basically, this binder course is added to reduce the cost of the construction. Now, between the binder course and surface course, another coating of the bitumen would be there, and that coating is called tack coat. Okay, and over there, that surface course would be built up. Now, over the surface course, another coating would be there to make the bituminous surface impermeable, and that is called seal coat. That is, it is sealing all the pores present over the bituminous surface. These are the different layers and their functions. Now, types of the flexible pavement. Now, there are different types of flexible pavement, and generally they are classified into three types. One is conventional layered flexible pavement. Now, conventional layered flexible pavements are the flexible pavements which we have already discussed, in where the pavement is consisting of different layers of the materials. Another one is full depth asphalt pavement. In the full depth asphalt pavement, what happens here? You will use directly only the surface course and binder course over the subgrade course. That is called full depth asphalt. Then another type is there, that is called contained rock asphalt mat. In that case, over the subgrade course, you will place one layer of the bituminous material, and between this you will place some coarse aggregate, and over there would be another layer of the bituminous material like sandwich. So this is called contained rock asphalt mat. Now about these questions, write short note on flexible pavements. Here you have to write down about this flexible pavement and their different layers along with the depth of each layer. Then what are the different components of the flexible pavement? Again, this would be similar. These are the different components, that is surface coat, seal coat, prime coat, etc. And again discuss about the various types of flexible pavements. These are the types of the flexible pavement. Now we have already discussed about the flexible pavement. Now there are another type of pavement which is called rigid pavement. Now these rigid pavements are made up of the concrete. Okay, that is, it is made up of cementitious material. Now, what is the primary difference between the flexible and rigid pavement? So, in the flexible pavement, whatever load is applied, after the application of the load, the pavement surface got deformed, and after some time, the part of that flexible pavement will be get restored. Therefore, it is called a flexible pavement. But in the rigid pavement, the hair would be stiffness. The stiffness would be higher, much more higher than the flexible pavement. Therefore, it will not deformed against the load. Now, if any higher loading will be applied over the rigid pavement, and if there is any deformation caused because of the higher loading. In that case, that deformation cannot be reverted. Okay, so basically that is the basic difference between the flexible pavement and rigid pavement. Now in the flexible pavement there would be different layers, but in the rigid pavement the number of layers would be reduced. So generally the rigid pavement is made over the subgrade layer, and in some cases you can place a subgrade subbase course or base course over the subgrade layer, but it is very limited. So these are the different layers of the rigid pavement. First one is paving quality concrete, that is that cementitious materials over the top surface. This one. Now this surface or these portions of the road can be either accompanied. It can be a plain cement concrete or could be reinforced cement concrete. Now one thing is there that the reinforcement doesn't imposed any additional strength to that material, to that pavement surface, rigid pavement surface, because here all the loading conditions will be in the compressive one. Therefore this reinforcement will little impact on the strength parameters of the rigid pavement, but this reinforcement will help to transmit load from one portions of the rigid pavement to the another. And another thing is, whenever some cracks would be there, then this reinforcement will help to get it together along with the other portions of the rigid pavement. So basically that is the functions of the reinforcement which is used in the construction of the rigid pavement. Now, rigid pavement characteristic, first one is rigidity. It doesn't deform under stresses. Then concrete air entrained increase resistance to frost. Now, if you use some air entraining agent, which we have discussed in the cementitious material, in that case it will increase the resistance to frost damage and de-icing or salt corrosion. Then reinforcement, maybe bars or mesh. You may use some steel bars or some mesh. Then continuous rigid pavements have heavy reinforcement. Now in the rigid pavements you need to provide some joints. Now why joints? In the flexible pavement there is no effect of the temperature stresses over the flexible pavement. But in the rigid pavement, there is very severe effect of the temperature stresses over the surface of the rigid pavement. Therefore, you need to provide some gap or some joints through which temperature stresses can be released. Now, what happens if you didn't provide adequate gap between the or joint? You could not properly design the joints. So in that case, during the summer time, what will happen, because of the increase of the temperature, the top layer of the concrete pavement will be increase in the length. Okay, and in the winter season it will contract, and again in the same season during the daytime the top layer will be get increased, but the bottom layer would be similar, because the temperature of the top and bottom layer would be different. Okay, therefore there would be some stresses which will be generated over the rigid pavement. Therefore you need to release the stress, and that stress can be released through the joints provided in the rigid pavement. Now in the rigid pavement there will be joints, and different reinforcement would be provided in the joint to transfer the load from one pavement component to the another component. Generally this joint can be transfer joint or longitudinal joints. Now, along these transverse directions, generally dowel bars are used, which transfer the load very effectively from the adjoining component. And in the longitudinal direction, another type of reinforcement is used, which is called tie bars, which will transfer the load in the longitudinal directions. Now surface course, this is the top layer which consists of the PCC slab, that is plain cement concrete slab, reinforced or continuously reinforced slab. It provides characteristics such as friction, smoothness, noise control and drainage conditions. Now in addition, it serves as a waterproofing layer so as to reduce or nullify any penetrations of the water in the bottom layer. Now this surface course can vary in thickness, but it is usually between 150 millimeter to 300 millimeter according to the traffic condition existing over there. Now below this you can provide base course. Now this is the layer directly below the PCC layer and generally consists of aggregate or stabilized subgrade. It provides additional load distribution, continues to drainage and frost resistance, uniform support to the pavement, and a stable platform to construct for the construction equipment. And over that surface only you will build your rigid pavement. So it will provide a plain and rigid surface for the construction of the upper layer. Now there are different type of base courses. So first one is aggregate base. So a simple base course of crushed aggregate has been common option since the earliest 1900s. So first, that is the most popular base course for the rigid pavement is crushed aggregate. Now another type of base course can be used as a stabilized aggregate or soil. Now stabilizing agents are used to bind otherwise loose particles to one another, providing strength and cohesion. Cement treated bases can be built to as much as 20 to 25% of the surface course of the strength. So in that case, what happens? You will need some aggregates, and along with that aggregate you will mix some stabilizing material like cement or like lime, etc., and above this you will build your surface course. Then another type of base course is dense graded HMA. HMA means hot mix asphalt. That is, in here over here you will mix some bituminous material or bituminous content with the aggregate and make the base courses, and over the base courses you will construct your rigid pavement. Then another type is permeable HMA. So in that case, there would be no finer materials in the aggregate content which would be mixed with the bitumen content. So and for these reasons that base courses would be permeable. That is called permeable hot mix asphalt. Now subbase course, this is the layer under the base layer. Now a subbase is not always needed, so therefore often be omitted. So you can use subbase layer if you feel that it is necessary for the condition prevailing over the site. Now the main function is minimize the intrusion of fines from the subgrade into the pavement structure, as in the case of the flexible pavement. It improves the drainage, it minimizes the frost and frost action damage, and provides a working platform for the construction of the upper layer. Now the subbase generally consists of lower quality materials than the base course but better than the subgrade soil. It is appropriate materials are aggregates and high quality structural fill. Then types of the rigid pavement. There are different types of the rigid pavement. So first one is jointed plain concrete pavement. Here the surface of the rigid pavement would be jointed. There would be longitudinal joint and there would be transverse joint, and no reinforcement is provided. Then joint reinforced concrete pavement. Here there would be joint as well as reinforcement would be provided. And composite pavements, here the base layer would be made up of hot mix asphalt, that is bituminous material mixed with the aggregates, and above this you will build your rigid surface. Okay, so as it is made up of both the bituminous material and cementitious material, therefore it is called composite pavement. Now another important is the difference between flexible pavement and rigid pavement. So if you discuss about this thing, that flexible pavement, it consists of series of layers with the highest quality materials at or near the surface of the pavement. Why? Because at the top layer the stress would be higher, and in the bottom layer that the stress would be lower. Therefore, in very high quality materials are used over the top surface. In the rigid pavement, it consists of generally one layer of the Portland cement concrete slab, or relatively high flexural strength. There would be very lesser number of layers. In general cases, it would be made up of only one layer, but in some cases you can use base courses or sub base courses. It reflects the deformation of the subgrade and subsequent layers on the surface. It is able to bridge over localized failures and area of the inadequate subgrade. So what does this mean? Suppose there are different layers in the flexible pavement. Suppose in the subgrade layer some damages has happened over there. So in that case, that damage will get reflected to the top layer. Suppose this is the top layer, these damages will get reflected on the top layer for the flexible pavement. But in case of rigid pavement, if there is any failure to the subgrade, then the rigid base will act as a breeze, and that will not be visible over the top surface. Its stability depends upon the aggregate interlock, particle friction and cohesion. As in the base course and sub-base course, no binding materials are used. Therefore, the strength of this flexible pavement will depending on the bond of the aggregates, and it is called interlocking properties. Therefore, grading of the aggregate is very important or very crucial for the flexible pavement. In the rigid pavement, flexural strength of concrete is a major factor for the design. Then it functions by way of load distribution through the component layers. So there would be different layers and the load will be transferred from layer to layer. Here it distributes loads over a wider area of subgrade because of its rigidity and high modulus of elasticity. Then temperature variation due to change in atmospheric conditions do not affect the flexible pavement, but for the rigid pavement, these temperature stresses are very crucial. Then flexible pavements have a self-healing properties due to the heavier wheel loads are recoverable due to some extent. But in the rigid pavement, if there is any deformation, it cannot be revert back. Now another important differences is for the flexible pavement, the initial construction cost would be lower, but for the rigid pavement, initial construction cost would be higher. Maintenance would be higher for the flexible pavement, but for the rigid pavements, that maintenance cost would be lower, and lifespan of the flexible pavement would be very much lower than of the rigid pavement. So this is all about today's class. Is it clear? Okay. In the next class, you just collect IRC 37. There will be some design portion. So it will be better if you collect IRC 37. Okay, IRC 37 maybe 2012. Okay, you just check it. Okay, another thing is there, as today you don't have that IRC 37, so I cannot start one new chapter. Okay, so in the meantime, if you have any confusions regarding the previous classes, you can ask me, or otherwise, I cannot continue your today's class. It will be end today, and there will be no second classes. So by next Saturday, we will complete the syllabus most probably. So if you do not have any confusion, you can leave the meeting.